Welcome everyone. Thanks for joining us today. A quick housekeeping note. All your lines are muted, so please post your questions or comments in the chat window. So now I would like to introduce Gurlin, our speaker for today's webinar. Gurlin has over 8 plus years of teaching experience, majorly in big data, Hadoop, and Spark. She also holds expertise in various high-end technologies like machine learning, clustering, Tableau, and Power BI, to name a few. Furthermore, she is a consultant to a few more organizations like Ministry of Defense Oman, Dell, etc. So before I hand it over to our speaker, I would request you, the audience, to take a quick poll. Thanks, everyone. Over to you, Gurlin.
Okay, thank you, Spandana. Thank you, Zed. Um, Hello, everyone. So I am Gurleen here. I will be taking over this presentation forward. Um, so yes, as she rightly said, if you have any queries or anything, you can discuss with her or put it in the chat box. And later after this, also we'll be able to discuss. If I'm audible, just let me know in the chat box because I am not sure if it is. Yeah, I hope I'm audible to everybody. And okay, yes, all right, thank you. Fine. So we're going to discuss about, as she said, that I've been taking up big data courses. I've been taking up data science courses as well recently. But today what we're going to do is we're going to discuss about this term which we often listen about, that is called as big data. And we will see that the emergence of big data happened in the industry and it was already there. And, what are the possible solutions to solve it? So if I say a very simple example, if I ask you guys just a couple of minutes back, you enter into the poll and everything. I know there are people who are attaining from different, maybe from different areas or many different grounds of that. And somebody from be from an IT background, somebody will not be from an IT background, but we come across this word of, big data, which is there. Now it's data we already know is something which, like I'm speaking right now, is also a data. But then what is big data and how does it come up, or how did it arise at a very rapid rate that everybody wants to learn about it or talk about it? So I'll give you a very layman example or a layman analogy over here is like, um, if I say, if I have to transfer maybe a small document or maybe a PDF file or even this PDF PPT which I'm discussing over, I could easily transfer it over the Google Drive or anything because it's a very, maybe KB is the size of this file. But let's say if I have to send you, all of you, across a virtual machine, or maybe a season of Game of Thrones, let's say one season of Game of Thrones, it's very difficult for me to give it through Google Drive. Maybe Google Drive will accept it, maybe it's in MBs or something. But what about all the 7 8 seasons which are there, and I have to transfer it to you and I have to give it to you over the internet? Now I do not have proper measurements to take that much of data, or I do not have proper methodologies. So instead of Google Drive, I will take another thing, which is maybe a WeTransfer or any other kind of equipment. Or the best part would be that I hand it over you through a hard drive. A hard drive can have 1 TB of the data, and then it can easily handle that much of it. So what I'm trying to say over here is, when my monolithic systems, when my traditional systems fall short of saving some kind of data, then it arises to what we call it as a big data, right? So a big data could be like, if I have somebody who has a pen drive, and the pen drive, the size of the pen drive is only like maybe 8 GBs or 16 GBs, then he or she cannot handle that much of data. Like if I give the whole season to them, they will not be able to handle that. They will not have the proper measurements to get that data. But if somebody comes up with a hard drive, it becomes very easy for them to handle that much of data. So that the thing is that big data for one organization could not be for the other case. And this is what we are fighting for. We have to prosper certain solutions. We have to conquer certain solutions in order to find out the optimized solution to handle that much of data. So how, if I talk about, so let's, yeah, we were talking about this because you will see 10 years down the lane, 5 years down the lane, or even just 2 months back, we know that, I'm not sure, like, I hope people are from all parts of the world over here, we're connected together. um, we are handling with this crisis of COVID-19 right now. You know that it happened like a few months back, and we have so much data related to it about it now. We have generated this data, and this data is very crucial for us. It's very crucial. It has to be saved somewhere, it has to be analyzed. People are working up on it, day and night, to find out what could be the possible solution to overcome this, or make a vaccine out of the whatever we are situation which we are going through. So what is happening is we're creating a numerous numbers of data every day, every single minute. Statistics are coming about the people who are diseased, who are affected, who are quarantined, what is happening in every single part of the world. So imagine the data which is being increased again and again. It is being compared to the SARS which happened, the swine flu which happened. So even the historical data have been kept. What were the protective measures taken at that point of time? They are checking for that and everything. So that could be helpful here. What we are doing is, this is what big data is. News are spreading. This webinar which we are attending, how maybe somebody is recording that, maybe somebody is, even if you're listening to this is what our data is. How we're transferring it is a data. So what I want to perceive over here is that we as human beings are as ourselves creating this much of data, are producing this much of data. And the problem, so big data is a problem basically. Big data is a characteristic is because I cannot handle that much of data, then it becomes a big data for me. So that's what. So there are certain features. So these are the maybe certain areas from where we are getting the data nowadays, like from emails, Word documents, spreadsheets, customer. This is very mediocre, but now if you see social media, you can imagine social media producing data at every rapid rate. You want to order a pizza, there is a phone call, just order it up. Sorry, there is an application, just order it up through the application, and it delivers it to you at your door. So it was not the case which was there like 10 or 15 years back. And imagine now you have watches connected to your phones, you have air conditioners connected to your phones, IoT is there. We have increased rapidly in the industry with IT and everything. We have made so much emergence in this world. So there are various areas where my data is coming from. So this, if I don't know whether I can zoom it up or not, but if you can actually read this thing. Amazon makes around 83,000 of online sales in a minute. So in every minute, this is a detail of what happens in every minute, how we are producing that much of data in every single minute of the day. If you see, like, so there's another 72 hours of videos are uploaded on YouTube, and they are all essential, they are all crucial. You cannot omit something, that this is data which might not be useful. I'll give you a very simple very there's a real time scenario which happened with us, not with us, as in it happened in a real time scenario, was that way back, like in 2000s, I remember there was a news which came up, article which came up, which said, there are flying choppers, flying helicopters and choppers, which have to be checked before every a flight take place. So there are system engineers who check these. There are system engineers who check the flag, the fans, the wings, and everything. So if you know what a chopper looks like or a helicopter looks like, it was a fighter army chopper, and there are two window panes on side of each side of this chopper. So the system engineer was checking onto this, and there are 70 nuts and bolts on each side of the window pane, and the error in the circumference of one nut and one bolt came out to be 0.01%. I mean, it was just slightly loose by 0.01% of that nut and bolt. Now, the system engineer said that it would not matter much of that, and he just gave a green signal, and it gave a green signal to fly. When the helicopter flew, And you know what happens is when it is in the air, the atmospheric pressure, which is inside the machine, inside the helicopter, and which is outside the helicopter, changes. And as soon as it changes, what happened is was the nut came off. Sorry, the bolt came off from the nut. And when one bolt came off, all the rest of the 69 also came off, and it was an airplane crash. So even that 0.01% of the data was important and had to be stored. So that's why we say it's nothing that, everything you do on the internet is to be saved, is to be secured and everything. You go on, if you use a social media website, you use, even if Facebook says 8 years down memory lane, 5 years down memory lane, it gives you like pictures, on this day, this happened. So it is not happening for one single person. You know how many people, like billions of people are there who are on the internet, who are making use of this internet, who are making use of this Facebook, and their all the data has to be stored. So evidently what we are trying to do is we as human race are ourselves creating that much of data, and we as human race ourselves are dealing with this problem of handling that much of data. It was it was estimated by Google that by the end of this year, the data which we will be creating is going to be the size of a cruise ship. It's going to be the size of a cruise ship, like your data centers and everything will be this much, that we will be creating like zillions or zettabytes of data. And it has to be, so major thing was, okay, I'm gaining this data, I'm creating this data. Another thing that comes up is I have to analyze this data. So that is the difference between I have records of people who are suffering from COVID-19. But what is the analysis? What I have gained from here? Maybe people have gained that people who have, low symptom, low immunity system are at higher risk, or people who are, uh, who are who are in the older age are finding a difficulty to. There's a difficulty in surviving for them, or people who have come from these areas are finding it difficult. So this is how you are coming up to conclusions. Why washing of hands was the solution to it? Why was sanitizing given there? They gave proper measures that the virus is this much big, this much small, and so on, and it breaks from it belongs to this family. So if you clean it with soap and water with 20 seconds, this will happen. They gave reasons. They came up to answers depending upon the data which they are collecting, right? So this is what big data is basically, if I say, is a collection of huge volume, because we're creating zillions of data. Velocity, because you see in 3 months itself how much data you might have concluded. If somebody is from a data science background or something, you will see packages have been created of coronavirus. Literally, there are packages in R programming in Python which have been created, which have the data set to for people to work upon on this, for machine learning enthusiasts or big data enthusiasts to work upon this and come up with proper solutions or something, if they can give a valuable insight to the scientists and stuff. Literally, if you want to check, you can go on Kaggle and you can check that they have given this like this. Variety. My data is not going to be always in a structured format. I cannot have my data always in a columnar tabular format. It is completely unstructured, majorly. Now, if I say completely unstructured, of course, you cannot perform analysis on something like, if I give like English text, if I give you, you cannot perform analysis on top of it. So what you try to do is you bring it into a semi-structured kind of a thing, or bring it into a structured form, and then only can perform analysis on it. So that was becoming one of the tasks. Like your log files are there, like your pictures are there, your images are there, videos, audio, whatever you're listening right now, if it is recorded, that becomes an audio kind of a data, right? So these are the three V's, which we call it as the three characteristics, or basically the characteristics or features of the big data. Now, so again, I say big data is basically a problem, and since every problem has a solution to it, we do have a solution for that. So I'll just take a moment and put up in as a wide I think Zoom has a whiteboard if it works. If not, just I'll use the paint option. And I hope this is, yeah, okay. Now, so big data became as a problem because they were finding it difficult to handle that much of data. And who finds it difficult? Who came up with this problem first of all is our beloved Google. So Google is called as a mother of IT, mother of information technology. Anything happens, we just Google it up. We say that. So Google was the actual person who was, finding it difficult, was the actual company who was finding it difficult to handle that much of data, handle enormous in large numbers of data and everything. So they said that it's what we will do is their basic ideology was, so they were storing data, let's say in one machine itself, currently whatever the machine you're working on, and let's say they were storing around 10 GBs at that point of time, way back I'm talking about, and they were storing it. Okay, and they were fine. Okay, like let's say what we will do is I will okay, I have to increase the data. Fine, why not? I will increase the data, or I will extend the the capacity of my own machine, of my current machine. 5 GBs is required, I can increase it. This is what we do. This is what generally we do, that if I have to if my system has SSD or whatever storage system it is having, if I want to have more storage, we provide external devices like a hard drive or a flash drive or pen drive or anything. But let's take it as a very layman analogy. If I talk about, let's say there is a table in front of you, and it's a heavy, quite heavy table on which your system is there, and you're working onto that. And if I say, sir, ma'am, can you just pull this table and move it from here to the other part or to the other room? Yes, you said, okay, fine, I can easily do that. You can pull it up and take it. But the table is quite heavy, so you were not able to do it. So you said, okay, I'll call somebody who's more muscular, who goes to the gym and all that stuff. And said, okay, I'll call my friend. And you try, and your friend also tries to pull this up, and he's unable to do this. So you said, okay, I'll bring another person who's more muscular than this guy. It makes no sense of doing this. What will be a common sense situation? What will be a common thing to do this? A layman can also tell this, is that why not two people or three people can actually easily pull this up? No requirement of gyms and everything. You can easily pull this up and move this table from one part to the other part. It's very simple. This is what was the idea behind. Why are you pressurizing one machine and giving all the, okay, I'll increase the size of this machine and everything? This is not required. Why not we distribute? So the concept came up with Google was, let's distribute the storage. So the first thing first which they said was, yeah, so let's distribute. Okay, so distribution makes it much more easier, in the sense I can have 10 GBs in one machine, so I can have another machine of 10 GBs. I do not require like supercomputers or anything, and I can easily work. So if more machines are required, of course there is always an option of scaling it up. So the first thing which Google gave was, let's distribute the storage. Okay, distributing of the storage. But now the limitation of working with distribution of storage was that processor also, like till now processor was only one. Like if I say, let me just put it here. Yeah. Now storage is there now, but the processor was only one. Like if this is my processor, though my storages are distributed, but this processor had to, sorry, the storage had to be taken from the processor and given. Okay, process. So the storage had to be taken from here, given to the processor. It will process, let's say, any kind of processing, like adding of numbers. The numbers are kept in the storage area, but the processor has to process it. So the storage is taken from here, given to the processor, processed, given back. Then the second storage goes and processes it and happens. So the pressure on the processor was still there was network bandwidth because of the traveling of the storage area to the process and bringing it back, and the task was not making any difference. Like the processor was still being pressurized of handling that much of the storage, and again these all these storages had to wait for the other storage to complete the task and then run it. So the concept that was given was that instead of just doing this distribution of storage, why not we distribute the processor also? So I can distribute like storage, I can distribute my processor. So whichever machine is storing my data, that itself will be processing my data. So I have the term, and that was the ground rule, and that is called as, we call it as distributed storage and distributed processing. Okay, distributed storage and distributed processing. And this whole thing was together called as distributed systems. And that's the basic ground rule or basic ideology of working with distributed systems. It's not, I'm not talking about any specific system, any Hadoop or SAP or anything. I'm just talking if there is a system which is called to be distributed system, this will be their ideology, that wherever I have my storage. So let's say if my system, your system, and a friend of yours, his system is there, his or her system is there. If we combine all of these three together, and if I have a file of 3 GB, so I can put 1 GB on my machine, 1 GB on your machine, and 1 GB on your friend's machine. And together, these machines can collaboratively, parallelly work together. And this parallelly made it much more easier. And that concept is called as MPP. If you've come across this term, that is called as massive parallel processing. There are many technologies, many tools which are making use of MPP, that is the massive parallel processing. Even Oracle has come up with this concept wherein the databases are transferred, databases are now working in parallel instead of sequential running. Instead of one database, they have this what you call opportunity of working with databases where you have this criteria. But again, the limitation of working with the databases when you're talking about big data is that it cannot handle certain data which is unstructured. So you cannot completely work onto that, right? So this was the call given by Google. Now, storage and processing were the two major things, if I say. So if I talk about storage, so storage, they said they created a tool called GFS, which stood for Google File System. Okay. And there's another one which is for processing. Which is a tool called as MapReduce. Now, the GFS is like your any file system. If you have come across Linux, if you know about Linux, basics of Linux, then you will be aware of that. Linux has its own file systems, has its own, the file systems basically. So similar to that, we have a Google's file system which sits on top of your Linux, which is sitting on top of your Linux, which works exactly like your extension files, the ext or NTFS files, and so on. Similarly, we have a storage area, which is called as for processing. So these were the two major concerns when we're talking about big data. Again, if I say big data is a problem, a solution to that problem was Google's GFS and MapReduce. Now, talking about MapReduce a bit over here, just to make you understand what MapReduce is. Now, there is a difference when I say MapReduce as in tool MapReduce, or it's generally call it as Apache MapReduce, or if I say you might come across like only just MapReduce algorithm or MapReduce logic. Okay. Now, there is a difference between this. The difference between MapReduce, Apache MapReduce, or Hadoop MapReduce is that it's a tool that uses this logic. And MapReduce logic itself is a logic which is being used by multiple other tools. Like Scoop, Flume, Kafka. There are other tools which are there which will be using this particular logic. But Apache MapReduce is a tool itself which uses this logic and it's written in a Java language. Now, considering this logic, what does a MapReduce logic say is that if I have, you know, if I give you an assignment or if I give you an assignment to solve 100 questions of mathematics to be solved. Okay, just a second. Okay, if I say if I have to solve 100, if I give you an assignment to solve 100 questions of mathematics, now either you can do it on your own, what you will do it like 100 questions are there, so maybe you take 3 hours to complete that task. Okay, an ideal situation would be like if your client has given us something, so you can have more people to with you, or let's say there is a friend of yours who can accompany you, so you give 50 questions to him, 50 questions to you, you yourself solve it. If you add two more people, so how many? 25 questions each, and each of them can easily work on individually, they can complete the task, and it will be much faster if you all do together. And so you're not waiting for the others to complete and everything, so you all can start together, right? So this is what mappers are. All the four people whom you hired for solving that questions, they are basically mappers. Mapper phase is one where everything is running in parallel, where they are working on individual data set. Okay, reducer is the one because I am the client over here, I gave you 100 questions. I do not want that, how many workers, how many people have you hired or not. I want you to give me the task as 100 questions in an order. Now you will become that person who collects the data from all of this, or collects the answers from all of your friends, sort it in an order and give it in like proper 1 to 100, and then give it back to me. So you will be acting as a reducer. So mappers are the ones which are working in parallel. Reducer is the one who has to wait for all the mappers to complete, collect the data from them, give it in a shuffle and sorting order, and then give the result forward, right? So this is what a MapReduce logic does. And this MapReduce logic is used widely in these tools of big data. We call it as a big data tools, and it is widely used over there, right? Now, if Google already had created this, okay, if Google had already created this, then what was the requirement of new tools like Hadoop and the other tools which came up? Now, to give you an idea of this, Google never used to give their source code or anything which is completely like as an open source or something. They used to give like white papers or something where they will tell that what is the mechanism they are basically using in creating this storage and the processing tool and stuff. So duck cutting was one of the person. Okay. Duck cutting was one of this guy who was working with Google, who was working with Yahoo and all these big shot companies. And he said that, no, this is a great concept and it will be required in future. It will be required, yeah, it will be really required in the future for everybody, because it is going to be inevitable that we have to be working on big data platforms and we have to handle that much of data, and it will be required. So duck cutting created a tool, and that tool was called as Hadoop. If somebody has read about Hadoop or anything, and if you will see, Hadoop is basically nothing technical. Like the naming has nothing to do with technicality. It's a funny story that how the word Hadoop came up. This guy duck cutting had a 5-year-old son. Now he might be 15 or 20, but like at that point of time he had a 5-year-old son, and that son had a yellow colored elephant stuffed toy, and that yellow colored elephant stuffed toy's name was Hadoop. So that's why he created a technology called Hadoop. So tomorrow if you create a technology, you can name your stuffed toys And yeah, you can make your own technologies like that. But another fun story after that, it's not so relatable, but is that after a few, when Hadoop came so famous and everything, um, so his wife, Doug Cutting's wife, was very upset on this fact that he did not create, like he created a tool based on this, and he did not make something from the family or something like that. And then he created a tool called Lucene, Lucene. Literally, I'm not making this up. Lucene was a tool which was built up, which was after his wife's name. And if you read about Lucene, Lucene is a tool which gathers data, like how. So he explained like how women gather gossips. That's why how Lucene gather data from multiple sources. But yes, that's how they have been building up tools and everything. But yes, this is how the history of Hadoop came up, and Hadoop emerged a lot and everything. But there are certain other factors, of course, which are technical factors, which Hadoop catered a lot of interest amongst people. And the major thing was that Hadoop was working on the same platform of storage and processing, but the major factor which worked was, the best part was that it was open source, and anybody from anywhere could actually make use of this open source tool and perform their I mean easily on your own system. And why I'm saying own system, because it works on cheap commodity hardware. It works on cheap commodity hardware, and that's the reason where it became so much efficient as compared to the other available tools. There were certain technologies like SAP was there, SAS was there, and SAP HANA, if anyone has come across HANA, was already existing tool at that point of time, which they came together with this concept of parallel processing and distributed systems. But this catered a lot of interest because of this reason. And if somebody goes by SAP HANA, SAP has a very huge licensing cost about their tools. So yeah, and this, when it became open source, it was so easy for people to make. Yes, the cluster setup and everything becomes a bit difficult, bit on a difficult part. But yes, open source, why not? Somebody would like to invest in something which is like open source available, and you can use your own systems. You do not need supercomputers to run a small POC also, if I say. Then why not? People would of course go with that. And again, Hadoop was using the same storage and the processing criteria over there. The storage tool which was there is called as HDFS, analogous to the same name like GFS. So we had Hadoop distributed file system, and for processing they were using the same MapReduce. Okay, so they were using the same MapReduce for the processing, which was a tool which was written in Java language, and it was widely available, open source, and everything was great. So let's resume back to the slide where we were discussing it about. Yeah. I'll come back to that. So data is valuable. Where is big data analysis majorly used? If you come across marketing analysis, imagine how the marketing of this webinar will be have done. How people are, anything you do on the internet, is all being stored for their marketing. I was just going through a data science thing, which we were discussing with some of our clients, is that, way back when, I hope everybody knows about this. Sorry, somebody wants to say something? Okay. Yeah. If everybody knows about this fact that Zuckerberg, this confession of Zuckerberg happened when he confessed about the, the leakage of the Facebook data. Before that, when he hired WhatsApp, or hired in the sense like he took over WhatsApp. Now WhatsApp's parent company has become Facebook. Facebook is the one which is there. Even in WhatsApp, if anybody uses it, you will see that it says that the messages from WhatsApp from one person to the others are encrypted, but it's not true. It's written in their security policy or service policy, basically, that you can, you have you anytime WhatsApp's parent company can make use of that data and for marketing values, and it's not viable until and unless it was the case until and unless when the confession happened. Now it's like completely secure. Earlier it was not the case. So anything you might also come across, like you are talking to your friend, and or you are just discussing it over WhatsApp or any social media or anything, you will start getting advertisements related to it. If I say I just now plan to go, like I cannot plan to go anywhere as of now, but let's say if I just plan to buy something, maybe buy a new furniture or something, I will start getting advertisements related to it all over the internet, because everything is connected, everything. So that's why even if you search for something on the Amazon, and they have abundance of data which is there, and they're just keeping a track of everything you do on the internet. So that's what marketing analysis, it's very valuable for what you are searching for, so that the advertisements are related to your search. Like if I start searching for makeup, I will get something related to makeup. But if somebody is searching for iPhones and everything, and they start getting something related to makeup, it makes no sense. So that's a wrong kind of a marketing. So this does not know. And if, to be honest, I tell you, your systems, your internet and everything, you know they tend to give you advertisements related to your gender also, or maybe your age also. Or even if you start, you say Facebook or anything, you will see, this is something which is relatable. How do you find it? Because they start, like, the news comes in such a way that it's very relatable to you, or the we share memes and jokes and everything which are posts which are there. It is something related to what a gender is, because how? Because of your behavior on the internet, on the your system. It explains that what, it predicts somewhere that what kind of this person is. Product recommendations, again I say Amazon is the best one. Demand forecasting. We have a lockdown in India for 21 days. People are predicting that this lockdown will increase or no, or it depends upon the situation in here. Fraud detection, how many people, fraud detection is the best way, where you use big data stuff and data science and all of that. So a lot of areas, a lot more. Healthcare is there, financial departments are there, social marketing is there, social e-commerce, all of this is where we use this data analysis. um, Okay. Data processing, we need large scale data storage. That is what we discussed, and large scale data processing. These were the two major issues that we were facing with when data storage came up. So disk capacity and performance. So this was an analysis which was done like way back in 1997. Sorry. If you see, the disk capacity was only 2.5, 2.1. The transfer rate was 16.6 Mbps, but the disk read time was 126 seconds. Coming to 2014, now it's 2020, so we have good amount of capacity, transfer rate, the disk reading time, and everything is good. So it's a comparison to, even in months it is changing. It's not now years, it's now months. We are changing at a very rapid rate. So this is all something which I was just telling you in that in the diagrammatical explanation. For decades, the goal was bigger, more powerful machine and everything. Copy the input from here. Distributed computing processing pattern. This is what we discussed in that one. So Hadoop became as a savior, as I said. So why Hadoop? What is Hadoop and everything? Uh, why it is important as of now in this point of time? I would say that is what the, if you go for the class of it, that will be beneficial for you to understand. We have enormous amounts of data. It has to be handled at anyhow. It has to be made useful for that, data mining, data handling, managing of the data, and then is what Hadoop comes up as a savior. It can handle, if I say, it can handle like terabytes of data very easily, which is not the case of there in your Oracle databases or any kind of databases or Excel sheets. People are still working on Informatica, Excel sheets and everything. So Hadoop came up to be that savior at that point of time. And this is what we have to learn in the future. Like if you go for the classes or anything, this is what you should be learning about. This is where that, where it will be used and how it will be used, or what does it basically do. So yeah, that will be from my side. If sorry. Um, yeah. So Spandana, would you like to take over, or who?
Yes.
Yeah.
So thanks for the wonderful insights on the emergence of big data, Gurleen.
Thank you.
Uh, Now I would request the sales manager Suraj to give you quick info of our programs. Over to you,
Right.
Suraj.
Thank you, Spandana. Am I audible to everyone?
Yeah, to me you are. So yeah.
Okay. Yes. So I just wanted to share my screen. So as Gurleen was discussing about data science and how the data is actually working out. So it has been a game changer across every industry. With high level digitization of processes, the generation of data is at peak. Thus, data science technology and tools are deployed to drive more productivity and across organizations. So keeping this in mind on how the market dynamics are changing, Great Campus has come up with a program that has been designed for enthusiasts like you uh, with collaboration with IBM. I'll quickly go through the program called Certificate in Data Science. The program covers the most popular and widely used analytical tools, which you'll be learning in the program. That is like you'll be introduced to data science, and after that, you'll be learning tools like Python, R, machine learning, Hadoop, Spark, and also, there's a lot of data as well. So how do you visualize the data and everything using Tableau? So all these things on a course level and a program level, you'll be learning all these things. So I'll just share it across. Yeah. Right. So this is a program called Certificate Program Data Science. So you'll be learning the programs, the courses basically on individual level. That is data science basics, where you will be learning all the data and statistics as well as the introduction courses. And then you'll be learning about data science with Python, wherein like how do you compute with mathematical computations using NumPy and everything. Then you'll be learning about machine learning going forward. Then with R, how do you forecast that? Like as she was talking about COVID, how do you use that mathematical libraries to visualize the data and everything? Big data, Hadoop and Spark, Tableau desktop. And with this, I'll be also taking you through apart from the IBM certificate, you also get lab environments like Jupyter, R, Scala, wherein you can also get your hands dirty about whatever courses you're learning. And furthermore, BFSI industries, energy, pharma, healthcare, e-commerce, you name the industry, there are many jobs available in these fields. The major drawback is that there are enough candidates who can talk about data science, but don't have the practical experience. So this is where I find the Grey Campus program is making a difference, as it brings you to a number of assignments and projects on all the key topics that you have learned on a course level, that are based on real scenarios to help you gain practical knowledge. Not only this, but the program also has two capstone projects, like this one, like as you can see, with this capstone projects, what you'll learn is basically, you'll be gaining all the real life based situations to gain practical knowledge, right? This training is a blend of self-paced courses, instructor-led courses, and you'll also get a 6 months access to it. Upon successfully completion of this course, you'll be getting an IBM certificate on both individual level and course level, and also Grey Campus certificate as well. Okay, right. So a Grey Campus Data Science PG program provides you with a unique blended learning experience at a nominal amount as compared to other providers in the market. As part of this webinar, we also are running certain discounts for the participants enrolled. You can also take up Grey Campus scholarship test to get additional, discounts in the program. So this is the URL I'll be sharing across. So this is the URL. You can log in through it. Our team will be sending across the URL for you. You can go there, log in yourself, take up the test, and our sales managers will contact you with the discounts and everything. All right. Thank you. That's it from my side. If you have any questions and all, Gurleen will be taking up from here.
Yeah, I'll be here. Thank you, Suresh.
Thank you. So now let us move on to the Q&A session. Please post your questions or comments in the chat window and Gulin will answer one by one. Over to you, Gulin.
All right. Yeah, if anyone has anything to ask or related to this or anything, please feel free to ask. Uh, That's a great question. What are the possible solutions to prevent the theft of data from an internet browser? See, the first thing is, of course, talking about the theft over there. What you can do is you can actually make precautions while you're working on the internet. If you're so, this is what a concept which I generally give is that. Whenever you're searching for flight tickets or tickets related to or anywhere, or if you're searching for something which you do not want it in a cache or something, so we go incognito mode. Generally when we talk about is on the tickets, on airline tickets. The reason is because, you know, if I'm searching for something from here to, if I have to go to Dubai, let's say, now I will keep on searching because I will wait. Okay, I will wait the other time the tickets will get low or not. But now the internet knows that I'm searching for it and I have to go anyhow. So if you do not want this kind of a situation, of course, just go incognito mode or a private window and then do it. Do not share any random information on the internet. Generally, when you have to enter through websites, you know, you have to put up your mail and everything. This was a concept which was given to us in way back when we were in school at that point of time, that create an ID which is for random, like for registering for certain things which you do not want to give your mail, or you do not want this mail to be accessed multiple times. So keep a mail ID which is for random things, like logging on to maybe certain sites which, you know, they just ask you for an email password or anything for their marketing purpose or whatever the kind is. But so, and keep your Google or whatever your account is on a professional level for certain professional sites and so on. So this is a way which you can actually prevent using certain kind of this thing. And yeah, use internet very wisely. For the rest, you can actually go for security courses on the internet. There are a lot of security courses. Difference between data science and data analysis, definitely, sure. See, I would say data science is, there is a very good picture, if you allow me guys to share with you. I have, I was just teaching a couple of days back to these people. Okay, yeah. Just a second. That was a very good picture actually. So that's why that explains a lot of things without speaking much about it. So to answer your question simultaneously, I would say data analysis is basically coming up with, answers related to whatever my data is. But data science is a bigger picture of the same thing. Just give me a single minute. Yeah, here it is. Yes, this one. So if you can see this picture of it, data science is a collection of all of this, what you said, like database, data analysis, data mining, data visualization, statistics, pattern recognition, artificial intelligence, robotics, IoT, and everything. So it's like to make the machine understand, to predict the values, and to make it more human like, to mimic it like a human being. That is what the science of data. So just to that's a broader aspect. Data analysis is a part of data science. If I say analysis is basically, if I have to find out the sale reports of a year, that comes up as data analysis. Okay, I find out this person, the sales were less in this area and this area. Predicting the sales in the future, depending upon the data analysis you have done, that is what a data science is. I hope the answer is okay. Yep. If there's anything else, anyone else has anything related to it, related or anything you have come across, or you know
Thank you, Gunjan. Thank you, guys.
thank you, Sman. Thank you
We
everyone.
hope the session has helped you. For any further questions or queries, please reach out to us at support@greycampus.com. Yeah, thank you. Stay safe.